In this video, we look at the second idea in 2D problems. Now, this one is on bearings. Now, bearings happening on the horizontal surface is entirely on the ground, all right? Even though if we have 3D problems later, even though say if you have things that goes vertically, say if you have a tree, all right, then what is the bearing of the tree from a ground observer, right? In that case, we still use the ground point of the tree, all right? We still use the ground point of the tree to measure the bearing rather than use the tree top, all right? Always the bearing is measured on the horizontal level. It will never go up in the vertical level, all right? Even though for vertical things, we'll measure the bearing on the ground level. And then there are two kinds of bearing, as you can see on this page. The two kinds of bearing, they are the true bearing and the reduced bearing, all right? Now, the bearings, just said, will be always starting from the northern direction, and then it moves in the clockwise direction, all right? So you see the examples here. We have the red, the green, and the purple. If we want to investigate the bearing, we always start the counting from the northern direction and rotate clockwisely, all right? Now, it's different from when we do CAST, sine, cosine, tangent. When we do CAST, we always measure the angles from a counterclockwise rotation, all right? This is 30 degrees, this is 45, this is 90, this is 120, and so on. This will be like 200 degrees, all right? We always measure the angle in a counterclockwise direction if it were CAST trigonometric function. However, this is different, all right? If we are talking about bearings, we always use clockwise direction to measure the bearing, all right? So there are two different conventions we have to pay attention to. And then on the other hand, we have what we call the reduced bearing. Reduced bearing, we reduce the numbers. The number is always between 0 and 90, all right? So we can use 4 different quadrants, as you can see here on the diagram here, right? We have the red, the green, the purple, and the yellow, all right? So each one of them will start counting from the northern or the southern direction, and then you rotate to the east or to the west. It can be clockwise, it can be anti-clockwise, right? For example, for all the thing in red, that will be north certain degrees east. For all the angles in this quadrant, that will be south certain degrees east, and so on, all right? So like I mentioned here, it starts at north-south and it turns east or west, all right? So this is reduced bearing. In the reduced bearing, the number is always between 0 to 90, all right? You will not have an angle greater than 90. So these are the basic ideas of the bearings. Now, people were making most mistake in the bearing that they confuse between bearing of B from A against bearing of A from B. They are two different ideas, as you can see these 2 points here. If we are talking about bearing of B from A, it is the point, it is the angle around point A. This is the green angle from A, all right? So the angle will be rotating around point A. On the other hand, if it is a bearing of A from B, if the bearing is from B, then the angle is around B, all right? So this is an easy way to make sure that you get the correct bearing. Now, when it comes to correct bearing, let's take a look at one DSC question, all right? Now, in this question, I think the most important thing is to look at where to put the numbers. There are 2 numbers. We have a red bearing, south 86 degrees east. Where should we put this red angle? On the diagram, which angle is 86 degrees, right? So we can take a look here. The bearing of P from O. Now, mind you, the bearing is measured from O. So the red angle should stick to point O. It will not be here. It will not be here. The red angle should be somewhere sticking around point O because the bearing is from O. All right. So it is bearing of P from O is south 86 degrees east. If you look at the diagram here, south certain degree east will be the angle in the 4th quadrant in this part, in the southeast region, all right? So that means southeast will be this direction. So the angle will be 86 degrees here. This is starting from south, going 86 degrees to the east, all right? Not this angle, not this one, all right? But the angle going from south to east, 86 degrees. So this red angle is 86. And then we have the green angle. Once again, it's also from O. Alright, so the angle is around O. So the bearing of Q from O is north 32 degrees east. So we start from the northern direction and turns east for 32 degrees. Alright. So this is how I put back the two angles, right? These are the most important thing in this question. If you put the angle at the wrong place, you will definitely get the wrong answer. Alright, now let's see what else they give us. They also tells us that the length, alright, P and Q, they are equal distance from O. They have the same distance from O. In other words, it is a fancy way of saying the length PO is the same as the length QO. Alright. So in other words, this PO and this QO, and they are the same. Alright, they have the same length, which means that it is an isosceles triangle. We can have these two angles, they must be the same. Alright. Okay, so let's see what does it ask for. It asks for the bearing of P from Q. Alright, the bearing of P from Q. Now the most important word is from Q. So we should get the angle around Q. Alright, if your angle is somewhere here, then it is wrong. The angle must be attached to Q because it is the bearing from Q. Alright, so let me put back the northeast southwest direction around Q. So this is Q, the northeast southwest around Q. This is north, this is east. We want to find the bearing of P from Q. So that would be this particular purple angle. Alright. So if you look at the quadrant here, it must be south certain degrees east. Am I right? It is in the southeastern direction. Point P is at the southeastern direction, southeastern-ish direction to point Q. Alright. So it must be south something east. So right away, you can eliminate the two answers A and B. Now, if you chose answer, for those who chose answer A and B, perhaps you mistake the angle of P from Q against the angle of Q from P. Alright. South certain degree west will be definitely this bearing. So should be took from P and from Q. Alright. Anyways, now that we know that the angle is from Q, so it must be south certain degree east. So we have to look at the quantity, how many degrees are there. I think we can make use of the isosceles angle triangle. We have 32 and 86 degrees, so we take 180 minus the two angles, then we have 62 degrees in between. Alright, it's 180 minus 86 minus 32. And then the two orange angles, they are the same because they are isosceles triangle, right? So we can get the orange angle as 180 minus 62 divided by 2. So each of these orange angle will be 32 degrees. Oh no, will be 59 degrees. Alright, 59 degrees. Am I right? Okay. Each of these orange angle will be 59. 180 minus 62 divided by 2. Okay, but how about this purple angle? How about this purple angle? Alright. Do not take 59 divided by 2, right? These are not half of 59. Once again, we can invoke some parallel lines idea. All this northern direction, they are parallel. Alright, so we have these parallel lines. We can have a pair of interior alternate angle. This is also 32 degrees. Right, because these two pair of angles, they are alternate angles, parallel lines. So the purple angle, you can find the purple angle now, is 59 minus 32. Alright, this purple angle will be 59 minus 32. And the answer goes to 27 degrees. Alright, so the answer is south 27 degrees east. We choose D as the answer. Alright. So this question kind of illustrates the idea of bearings. I think the most important thing for bearing, in addition to angles of elevation, angle of depression, is to understand the idea of this reduced bearing and whole circle bearing. And sometimes it is rotate clockwise, sometimes it is rotating anti-clockwise. I have to say it is kind of confusing. Alright, but if you are good at it, if you spend some time and be familiar with it, then the rest is quite similar to angles of elevation and depression. Okay, so in the next part, we'll have a more complicated example to look at.